welcome to this deep dive. We are really thrilled to have you with us today.
Yeah, I've been looking forward to this one. It's a dense one, but it's great.
It is. So our mission today is to explore this truly mind-bending submission to Curt Jaimungal's core contest for the Theories of Everything channel.
Right.
We're looking at a paper titled Celominisignum, the Similarity Theory. It's a framework put together by researcher Howard DeLaCruz-Bancroft and mathematical physicist Dr. Prosper Akrobotu.
And, if you've ever felt a fundamental frustration with how modern science explains reality, you are really going to want to hear this.
Yeah, absolutely. Because right now, physics is essentially playing two entirely different games, right? With two completely different rule books.
Pretty much. Yeah.
Like when you drop an apple, it falls to the ground. That's gravity. It's predictable, macroscopic, and it just makes intuitive sense to us.
But then if you zoom all the way in, past the apple, past the molecules, down into the quantum realm, the rules completely break down. The apple is suddenly like teleporting, doing backflips, and operating on what appears to be pure chaotic randomness.
Exactly. And the overarching problem of our era is that the macroscopic world of gravity and that microscopic world of quantum mechanics, they simply refuse to talk to each other.
They operate on scales that seem to have no shared language whatsoever.
Right. And for decades, the scientific community has essentially just accepted that, gravity's refusal to scale and the apparent randomness of the quantum world are two completely separate, massive mysteries.
But this paper asks a really dangerous question. What if they aren't separate at all?
Yes.
What if they're actually symptoms of the exact same hidden structure?
Okay, let's unpack this. Because the origin story of this theory is fascinating, and it didn't start with someone trying to, unify physics on a chalkboard.
Far from it, actually. To understand where this framework comes from, you have to understand the incredibly locked-down, constrained environment that it was born in.
Yeah.
This started with a highly specific, microscopic mystery at the Los Alamos National Laboratory.
Right, LANL.
Exactly. So DeLaCruz-Bancroft had this long-standing involvement with the supercomputing challenge there, spanning from the 90s as a participant all the way through the 20s as a mentor and contractor.
And he was deeply immersed in analyzing these 1 nanometer scale electron microscopy images of two-dimensional graphene, right?
Yes.
And I just want to make sure we picture this correctly for you listening. Graphene is a single layer of carbon atoms, and it's famous for forming this perfectly repeating symmetrical hexagonal lattice.
It looks like microscopic chicken wire.
Right, chicken wire. But he wasn't seeing perfect chicken wire, was he?
No, he was seeing anomalies. He observed these strange asymmetrical variations in the graphene layers.
Like glitches in the structure.
Exactly. At that microscopic scale, the structural perfection was occasionally interrupted by these complex branching deviations. And he really wanted to understand the mechanism driving those tiny imperfections.
Which makes sense.
Right. And the standard approach would be to get back into the lab, isolate more samples, run extensive physical diagnostics. But, we're talking about early 2020.
Right. Pandemic hits.
The COVID lockdowns shut down physical access completely. Scientists are sent home.
Yeah.
Access to the analytical tools and the physical lab space at LANL is just cut off.
Which is, the ultimate roadblock for an experimental researcher. But this forced constraint is where the massive pivot actually happens. Because he can't use physical matter. He shifts entirely to AI-assisted platforms and computational simulations. He actually starts using Unreal Engine 5.
Which is wild.
Right. That's the software developers use to render high-end video games. And he's using it to model these complex physical systems.
And while he's trying to simulate the formation of these graphene sheets digitally, he hits a wall.
Yeah.
The baseline physics engines just cannot reproduce the specific branching anomalies he saw in real life.
Because they're relying on standard random interactions.
Exactly. So the only way he can force the computer to generate those real-world asymmetrical structures is by manually injecting what he calls a viral-like perturbation function into the code.
A perturbation function.
Right. It's an algorithmic routine that disrupts the perfect order and literally forces the system to reorganize around the flaw.
And that moment in the simulation is the spark. He realizes that a specific algorithmic process of disruption and reorganization is required to build reality at the 1 nanometer scale.
Which begs a staggering question, right? Could this exact same process of informational disruption and reorganization be happening everywhere at all scales of the universe?
Wait, I have to push back here.
Sure.
You're telling me a smudge on a microscopic piece of carbon combined with a guy being locked out of his lab during a pandemic spawned a grand unifying framework for how the entire universe operates. I mean, that feels like a massive, almost reckless leap in logic.
I get that. But if we connect this to the bigger picture, paradigm shifts often require this exact type of force constraint.
Okay, how so?
Well, by being lined out of the physical lab, the methodology was forcibly shifted from observing physical stuff, right, to observing computational rules.
Oh, I see.
When you stare at an electron microscope, you're looking at the end product. When you're forced to build that product in a simulation, you have to figure out the underlying code that generates it.
Right.
And when the conventional code, which assumes reality, is built on fundamentally random interactions, completely failed to reproduce reality, he was forced to fundamentally flip his core assumption about the universe.
And that flip is really the beating heart of the theory. The paper calls it the primacy of informational order.
Even the name of the theory, Celominisignum, is Latin for hidden smallest symbols.
Hidden smallest symbols, I love that, because traditionally, the scientific consensus assumes the universe started with random physical stuff, just particles bumping into each other chaotically in the dark until eventually they just happen to form ordered structures.
But this theory asserts the exact opposite.
Right. It argues that order and information are the primary baseline of the universe. Light and physical matter are only secondary expressions of that information, and randomness is tertiary.
It completely demotes randomness.
Exactly. Randomness isn't the foundation. It's just a disruptor introducing entropy into a system that is already fundamentally organized.
And think about the mechanics of that claim. Information isn't just a byproduct of matter existing. Information is the blueprint that tells matter how to exist.
Yeah.
The framework actually maps out how this primary information scales up into reality through 4 levels of order.
Let's walk through those.
Sure. So it starts at the absolute base with structural order. This is the raw geometry, the mathematical constants, the pure logical relationships of the universe.
Okay.
From there, it scales up to functional order, which is the mechanism that allows a system to persist over time, like the homeostasis in a living cell.
Right.
Then as those systems interact, you get relational order, which governs mutual coherence. This is what keeps an ecosystem in balance, or potentially what keeps a galaxy bound together.
And
Finally, all of that culminates in emergent order. These are highly complex behaviors like human consciousness, intelligence, and civilization.
So to put it in incredibly simple terms, it's almost like reality is a multiplayer video game.
Okay.
The base code executing on the server, the hidden information is primary. That is the actual reality.
Right.
The graphics rendering on your screen, the light and the physical matter you interact with is secondary. It's just the expression of the code. And the glitches, the lag, the static, that randomness is tertiary.
That is a brilliant way to conceptualize it.
We've just spent the last century exclusively studying the pixels on the screen, wondering why they sometimes act randomly, instead of looking at the source code driving them.
Exactly. And what makes this paper compelling is that they aren't just philosophizing about source code, They draw on established, cutting-edge experimental physics to prove that information dictates physical reality.
Like Stephen Hawking's later work.
Yes. Hawking's work regarding black holes.
Yeah.
For a long time, physics thought black holes destroyed everything, but the mathematics suggest the information about the matter that falls in is preserved on the event horizon.
So the physical stuff is crushed, but the information persists.
Precisely.
They also heavily cite the work of Lean-Vestergaard Howe, which is absolutely mind-blowing.
Oh, it truly is.
Yeah.
Dr. Howe ran an experiment where she took a pulse of light carrying specific information, and she slowed it down and transferred it entirely into a physical mass.
Wait, she turned light information into mass?
Yeah. Specifically, she used a Bose-Einstein condensate, which, if you were unfamiliar, is essentially a cloud of atoms supercooled to just above absolute zero. So they clump together and act like one giant quantum superatom. She transferred the light's information into this physical matter. The matter held it, and then she recovered that exact information back into light later.
Which fundamentally proves that information, light, and physical mass have a totally fluid, interchangeable relationship.
Exactly. They aren't different things.
Yeah.
They're different states of the same underlying data.
And the authors also point to computed axial lithography, right? That 3D printing technique.
Yes, CAL. Instead of building an object layer by layer with plastic, you project intersecting patterns of light into a liquid resin.
And the resin just cures based on the light.
Right. It solidifies into a 3D physical object based entirely on the mathematical patterns contained within the light beams. The light isn't just bouncing off an object so we can see it.
The information in the light is actively commanding the liquid matter to organize into a solid structure.
Exactly. And when you digest the mechanics of those experiments, you start to see why the authors prioritize information.
Right. And if information is the primary driver of physical reality, it fundamentally alters how we have to look at the macro forces of the universe.
Which brings us to their radical redefinition of gravity.
Right. Rule 3 of their framework, gravity as relational coherence. This attempts to solve the fundamental problem we discussed at the top of the show.
The disconnect between the macro and the quantum.
Exactly, because the traditional view of gravity is just a brute, isolated force. A massive object bends space, and smaller objects fall toward it.
But Celominisignum asks a mechanical question. What if gravity is actually an algorithmic process? What if it's a mechanism whose entire job is to preserve the coherence and relationships between ordered systems across different scales?
And to explain the mechanics of how information could possibly pull physical matter together, the authors propose a theoretical structure called the IEMA.
The informational ether matrix array. It's described as a subplank informational scaffolding.
Okay, let's clarify that, because informational ether matrix array sounds like dialogue from a cyberpunk movie.
It really does.
If the Planck length is essentially the absolute smallest measurable pixel of physical reality, something that is sub-Planck means it operates entirely beneath the measurable physical universe.
Exactly. They refer to it as the new zero. It's the transition zone, this hidden mathematical grid where pure potential information aligns and translates into observable kinetic reality.
So it's the invisible architectural framework that dictates how physical particles are even allowed to arrange themselves.
Right. And here's where Dr. Prosper Akrobotu, the mathematical physicist, brings the heavy artillery.
Bro, the math.
Yeah. He takes this conceptual subplank scaffolding and integrates it directly into Albert Einstein's actual equations, specifically the stress-energy tensor.
Okay.
Now, if you aren't looking at orbital mechanics every day, Einstein's equation essentially proves that the geometry of space-time, what we experience as gravity, is determined by the distribution of mass and energy.
Mass tells space-time how to curve, and space-time tells mass how to move.
Perfectly said. And the standard formula uses the variable T-mu to represent that mass and energy. But Dr. Akrobotu proposes adding an entirely new mathematical symbol to the equation, C-mu.
C-mu.
Right. That new symbol represents the informational curvature contribution. The authors call this the site extension, the stress-energy information tensor.
Okay, here's where it gets really interesting. Because the core proposal is that mass and energy alone do not curve space-time.
Right.
Mass, energy, plus the density of their informational organization is what curves space-time. The paper uses this great analogy of two Lego cities.
Oh, I love this one.
Imagine you build two cities using the exact same number of blocks. They possess the exact same mass. But city A is perfectly organized. It has interconnected roads, structural support, coherent neighborhoods.
Right.
And city B is just a chaotic, random pile of those exact same blocks. CELT poses the question, does the intense relational organization of city A change how it interacts with the underlying subplank grid?
Does its informational density alter its gravitational footprint compared to the random pile?
Exactly.
And I want to focus on the how here because it's crucial. The theory suggests that highly organized systems possess a dense web of relational coherence. They are locked into the informational scaffolding much more tightly than a random pile of matter.
And that tightness exerts a physical pull.
Yes. That dense mathematical relationship exerts a literal pull on the fabric of reality.
Right.
And if this mechanism is real, the real-world implications are staggering.
Because it means organization precedes physical reality.
Precisely. If informational coherence contributes to physical space-time, then measuring a system's relational organization could act as an ultimate early warning system.
Oh, wow.
You could theoretically detect the upcoming collapse of a forest ecosystem, the structural failure of a steel bridge, or a phase transition in a chemical compound, simply by measuring the degradation of its informational coherence.
Long before any physical changes manifest.
Exactly. The code breaks down before the graphics glitch.
I love that idea, but I have to play the skeptic here.
Please do.
This is the exact trap a lot of grand theories fall into. It's a beautiful narrative, it uses elegant math, and it makes intuitive sense. But a theory in physics is entirely useless unless it possesses strict falsifiability.
Karl Popper 101.
Right. Popper taught us that if you can't design an experiment to prove a theory wrong, it isn't science, it's just philosophy. So how do they actually propose putting this invisible framework on trial?
Well, they dedicate a massive portion of the paper to exactly that. They provide a comprehensive toolkit for falsifiability, primarily relying on advanced computational simulations and relational coefficients to see if their mathematical rules predict reality better than our current models.
Let's look at how they test this, starting with simulation modeling. They propose simulating complex physical phenomena, like the radiating ripples of waves in a pond.
Yeah.
The experiment is simple. You build one digital model using standard baseline physics, one using entirely random generative rules, and one using the Celominisignum relational algorithms.
And then you compare.
Right. You compare the digital outputs to high-speed video of actual real-world pond waves. If the Celominisignum model does not mirror the real-world physics significantly better than a random or baseline model, the theory dies right there.
And they also test the mechanics of that hidden scaffolding we discussed, the IEMA. The hypothesis is that underlying instructions govern the stability of physical structures.
The Lego instructions.
Right. If you run a simulation where agents are building a structure and you provide stable, coherent instructions, they should build something that persists.
Makes sense.
But if you provide randomly fluctuating instructions or no instructions at all, the structure should collapse. If, in a simulation, a system without underlying informational scaffolding organizes and survives stress just as well as one with scaffolding, the concept of the IEMA is proven false.
And survival under stress is a huge part of how they test this. They look at coupling and decoupling dynamics.
Right, the storm analogy.
Yeah. Imagine a group of people out in a massive, violent storm. If they hold hands tightly and move as a synchronized unit strong coupling, they can resist the wind and survive.
But if they let go,
If they start letting go of each other, operating independently, the storm scatters them. The framework applies this exact logic to quantum particles and magnetic fields.
okay,
If observation shows that a weakly coupled, disorganized particle system survives a thermal stress event just as well as a strongly coupled, relationally dense system, the entire relational coherence theory falls apart.
it demands that organization is the sole mechanism for persistence.
Mm-hmm.
And they quantify this organization using something called the Informational Alignment Coefficient, or IAC.
IAC.
This measures how well the disparate parts of a system align toward a shared state of coherence. Think of a soccer team. A team with a high IAC passes the ball, moves in synchronization, listens to the coach.
And a low IAC team.
A low IAC team runs around the field randomly, ignoring each other. The mathematics dictate that the high IAC team will stay organized under the pressure of the game much longer.
Which flows naturally into another metric they use, the Informational Order Coefficient, or IOC. This one deals with the concept of identity, and the mechanism here completely shifted how I think about persistence.
It's fascinating.
It asks, how does a physical system maintain its identity when its physical parts are constantly changing?
It's basically the classic ship of Theseus paradox, but applied to physics.
Exactly. The paper uses the analogy of a school. If you replace every single teacher, student, textbook, and classroom overnight, the school entirely loses its identity. It is a functionally different entity.
Right.
If you replace those components randomly and chaotically every single day, the school descends into dysfunction.
But if you use a gradual, highly organized replacement model, preserving the internal relationships in the culture while slowly swapping out the physical components over time, the school's identity remains completely intact. Because the profound mechanism at play here is that identity, the self of any system, is not tied to its physical material.
No.
It is tied entirely to the relational organization of that material.
Think about your own physical body. Your cells are constantly dying and regenerating. The actual physical atoms and molecules that make up your brain and your heart today are almost entirely different from the atoms that made you up 10 years ago.
You are physically not the same person.
The only mechanical reason you are still you, with your memories and your personality, is because of relational persistence. The informational blueprint remains perfectly intact, actively organizing the new building materials as they swap in.
And to reinforce the rigor of their methodology, they state clearly, if an experimental system where every component is replaced instantly or randomly maintains its functional identity just as well as a highly organized high IOC system,
the theory is invalid.
Exactly. The Celominisignum framework is invalid. The theory lives or dies on the premise that structured organization is the only way a system survives the entropy of time.
Which introduces a really fascinating paradox.
Oh, yeah.
If strict organization and informational order are the ultimate keys to surviving the chaotic storms of the universe, shouldn't the universe logically strive for absolute, perfect, crystalline symmetry in everything it builds? Why isn't everything perfectly symmetrical?
You would naturally assume that perfect order equals perfect stability.
Mm-hmm.
But the mechanics of the physical world show us that perfect symmetry is actually incredibly dangerous.
Dangerous.
Yes.
Yeah.
And this leads to their tests involving chirality and informational asymmetry.
The bridge analogy they use explains the why behind this beautifully.
It really does.
If an engineer builds a bridge that is flawlessly, perfectly symmetrical down to the molecular level, it is actually highly vulnerable.
Right.
If a specific frequency of vibration hits that bridge, say, from a gust of wind or marching footsteps, that perfect repetition causes destructive resonance. The vibration echoes and amplifies across the perfect symmetry until the bridge literally shakes itself apart.
But if you build that bridge with controlled informational asymmetry, tiny constrained differences, or what physicists call chirality, those slight imperfections break up the resonance.
The structure absorbs and dissipates the vibration safely. It survives.
What's fascinating here is how they mathematically define that survival state. Long-term stability does not come from maximum order, because maximum order is mathematically brittle.
Right.
And it clearly does not come from maximum randomness, because that dissolves into chaos. The mechanism for survival requires dominant coherence with constrained adaptive variability.
Dominant coherence with constrained adaptive variability.
Exactly. The system must be mostly ordered, but possess just enough flexibility to absorb shock.
They illustrate this with the concept of stacking blocks using a golden ratio, specifically an 8.5 relationship.
Yes, the 8.5 model.
If you stack blocks in a perfectly neat, rigid tower, it's brittle. One slight bump to the table and the whole tower snaps and falls. If you just throw the blocks in a messy pile, they tumble over immediately. But if you build a stack that is structurally organized, but has some built-in asymmetric flexibility, an 8-to-5 ratio of order to variance, that stack can sway when the table is bumped, it survives the kinetic stress.
Yeah.
So what does this all mean? Does this mathematically prove that the flaws, the glitches, and the tiny asymmetries in nature aren't mistakes, but are actually required structural load bearers for the universe?
That is exactly what the mathematics suggest. Science doesn't advance by protecting idealized notions of perfect symmetry. It advances by discovering these deeply nuanced asymmetric relationships.
Wow.
The authors even posit that cosmological expansion itself, the universe stretching out, might not just be an explosion moving outward, but a regulatory mechanism balancing the density of order and entropy so the universe doesn't become too brittle to exist.
It is just a breathtaking way to view the mechanics of reality. And to be completely fair to DeLaCruz-Bancroft and Dr. Akrobotu, they do not claim they have written the final, undisputed laws of physics.
No, not at all.
They explicitly state in their conclusion that Celominisignum is offered as a research tool. It is an invitation to the scientific community to ask fundamentally better questions. It is a framework that is demanding to be tested in supercomputers and particle accelerators.
Because, the universe certainly doesn't care about our rigid academic silos. Biology, quantum physics, computer science, sociology, they might not be distinct fields of study at all.
Right.
They might simply be different macroscopic expressions of the exact same hidden informational rules operating at different scales of reality.
And understanding that reality is built on information leaves me with one final, deeply provocative thought. It's not something explicitly tested in the paper, but it is the logical extreme of their theory.
Okay, what is it?
If information and relational order literally shape the physical reality we inhabit, and if, as they theorize with the SAID equation, informational density literally exerts a gravitational curvature on space-time, where does that leave us?
Oh, I see where you're going with this.
Because humans represent the absolute pinnacle of level 4 emergent order. Through our consciousness, our massive data networks, and our complex civilizations, we are generating unparalleled amounts of relational information.
Right.
Could our collective human thoughts, the highly structured way we organize our global societies, and the sheer volume of coherent data we create actually be exerting a literal, measurable physical force on the fabric of the universe?
Man, It is a profound implication. If informational curvature is a genuine mechanical force, then how we organize ourselves, how we structure our societies, and how we process information matters on a fundamental gravitational level.
It forces you to look at the world through an entirely new lens. The next time you drop an apple, or you watch a glitch on your computer screen, or you see a perfectly imperfect leaf in your backyard, ask yourself what the hidden code beneath it all is actually trying to tell you.
Absolutely.
Thank you for joining us on this deep dive. Keep questioning the rules and keep looking for the hidden patterns.